Right now I'm camping at Gunfordshire Park. It is winter, but the fire is amazing. The snow is all around us, and I often wonder what is up in the skies. Every camper loves to stargaze, but you think every single light you see up there is a star, like our sun, with possible planets orbiting it. So, is there life out there? I often wonder that.
In this video, you will briefly learn how Hubble became to be before moving on to an in-depth view on its greatest discoveries in the extreme deep field of space, and also what will come to follow in the legacy of Hubble. So now, please put YouTube on HD setting and plug your computer into the TV. It will be worth it. The construction of the Hubble Space Telescope began in 1979 with the production of its primary mirror that captures starlight from up to billions of light years away. Seen here at its final stages of completion in 1981, the mirror has a diameter of 8 feet or 2.4 meters. It functions by concentrating light into a smaller mirror, in which it is then reflected into the instruments to be processed into the many famous images we see today. Hubble's mirrors were ground so precisely that they do not deviate from a perfect curve by more than 1/800,000th of an inch. If Hubble's primary mirrors were scaled up to the diameter of Earth, the biggest bump would be only 6 inches or 15.2 centimeters tall. At a cost of a then $1.5 billion, Hubble was completed in 1985 and was ready to be launched. However, due to the Challenger disaster of 1986, the launch was delayed. Here, Hubble is awaiting deployment. The bus-sized Hubble Space Telescope is carefully being transferred from the surgically clean payload change-out room in a Discovery's cargo bay at the Kennedy Space Center. Finally, on April 24, 1990, the Space Shuttle Discovery lifted off from Earth with the Hubble Space Telescope nestled securely in its bay.
Your visors and initiate your O2 flow, and you all have a good trip. Roger that, 10 work.
Start. We are go for main engine start, T-minus 6, 5, 4, 3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
Mission Control, Houston.
Roll program. Roger, roll, Discovery.
The roll maneuver puts the vehicle in the proper launch plane. Guidance officer confirmed.
The following day, Challenger had safely reached a height of 559 kilometers above the Earth's surface. With the help of a Canadian-built robotic arm, Columbia's payload was slowly unloaded, and Hubble was released into space and began to orbit Earth 14 times a day. Now Hubble was ready to peer into the vast unknown of space, offering mankind a glimpse upon distant, exotic cosmic shores yet to be described. Or was it? One of the key aims of the astronomers who designed the Hubble Space Telescope was to use its high optical resolution to study distant galaxies to a level of detail that was not possible from the ground. Positioned above the atmosphere, Hubble avoids not only man-made light and air pollution, but also Earth's natural atmospheric airglow, thus allowing it to take more sensitive visible and ultraviolet light images than can be obtained with ground-based telescopes. Within weeks of deployment, Hubble began sending back its first images. However, with great disappointment, there was a big problem. Although the images were still better than any ground-based telescope, they are still not as clear as Hubble was designed to capture. Here is a raw image of galaxy M100. The spiral-shaped galaxy is estimated to be tens of millions of light years away. The problem was discovered and solved. The curvature of the primary mirror was flawed. Although it was the most precise figured mirror ever made, it was still off by 2.2 micrometers. Light was not being reflected and concentrated over a small enough surface area on the secondary mirror. The results were catastrophic, so in 1993 a spacewalk mission was launched to outfit Hubble with a corrective lens. which could be compared to an everyday contact lens. Hubble also received upgrades to its camera system, solar arrays, and gyroscopes. The crew of 7 worked hard, and after 5 days of spacewalks, completed one of the most complex installations ever done before. The mission was deemed a success, and with high hopes, Hubble was then pointed back at galaxy M100. The image came back much clearer with never before seen clarity. Here is a comparison of M100 before and after. The difference was very pronounced. Finally, after 14 years since construction, and another $700 million spent on repair, Hubble was now living up to expectations. Hubble would soon prove to be very much worth the cost and time. In 1995, astronomers decided to do something that had never been done before. In the northern hemisphere, they pointed Hubble at a small patch of black sky away from the Milky Way. If you were looking up at the night sky, the patch was no bigger than the amount of space a grain of sand held at the tip of your fingers would block. Many astronomers were against using Hubble's precious time out of fear that images would just come back being black and devoid of stars. The images that did come back were astonishing. This image was pieced together from 342 separate exposures, taken over a period of 10 days, revealing up to 3,000 younger galaxies at a distance of 12 billion light-years away. Zooming in on this section reveals faint, distant, irregular, and spiral-shaped galaxies being clearly visible. What was also a discovery was the number of galaxies that were redshifted, meaning Hubble was close to its limit of how far it could see invisible and ultraviolet light. To see this far into a galaxy and back in time became known as Hubble's deep field vision. Going much beyond this, capturing infrared light would become important. 3 years later, in 1998, after upgrades from a second service mission, Hubble peered into the deep space again over many days. This time the patch of black sky was in the southern hemisphere. The result was similar, meaning the universe must be uniform. Hubble again found thousands of more young galaxies. This image, like the deep field north, was pieced together and became the deepest visible ultraviolet light image of the universe ever taken at the time. In 2009, after the last service mission, Hubble was ready to amaze the world yet again. The telescope continued to push boundaries, this time by seeing into extreme deep space. Hubble was refocused in the same patch of southern sky as the year before, and used its new near-infrared camera to capture light from even further away. Galaxies were found up to 13.2 billion light-years away. In 2012, after years of compiled exposures, we can now visualize flying through the universe for billions of light-years back at a time, to what it looked like up to 450,000 years after the Big Bang. As you see, the universe is undeniably a massive place. For perspective, we will now backtrack to Earth from the patch of sky that Hubble's extreme deep field captured. It is fascinating to try and fathom just how big the universe really is. If you were to combine all the beaches on Earth, there would still be more stars than grains of sand. All these stars combine to make a total of 200 billion different galaxies, each of which containing billions of stars, many of which have planets orbiting them. Ask yourself this question: are we really alone? Aside from deep space, over the years Hubble has captured many amazing images closer to home. At 23 million light-years away, here is a large whirlpool galaxy. It is classified as an interacting grand design spiral and contains over 100 billion stars. Coming closer, inside the Milky Way, Hubble has also captured many nebulas, like the Orion Nebula. In this cloud of dust, more than 3,000 stars are forming. It is 1,344 light-years away, and is the closest region of massive star formation to Earth. In our solar system, Hubble has also been focused on some of our planets like Jupiter. Hubble's mission was only supposed to last 20 years, up until 2010. However, Hubble is continuing to amaze us well into the second decade of the 21st century. Many wonder, what is next after Hubble? The answer to that is the James Webb Telescope, which is currently being constructed with a launch date of 2018. The telescope's planned mass is about half of Hubble's, but its primary mirror, made up of many smaller mirrors, has a collecting area of about 5 times larger than Hubble. The mirrors are coated in gold and beryllium. Here is a comparison of a woman standing beside the James Webb and Hubble's mirrors. Hubble's has a diameter of 8 feet or 2.4 meters, while the James Webb's has a diameter of 21 feet or 6.5 meters. At an estimated $8.7 billion of combined construction with 5 years of operation cost, the James Webb Space Telescope's launch is highly anticipated among people around the world. Compared to Hubble's orbital distance of 559 kilometers above the Earth's surface, the James Webb will travel and deploy itself 1.5 million kilometers away. That's more than 1 million kilometers further than the Moon. At the moment, there is currently no planned mission if something were to go wrong. It simply might just be too far away. The James Webb is not only a successor to Hubble, but also the Spitzer Space Telescope launched in 2003. Although the Spitzer is not as powerful as Hubble, it can do what Hubble can't, that is capture infrared light. Spitzer once was pointed at the same deep field south patch that Hubble captured. The visible and ultraviolet light image is on the left that Hubble takes, while on the right, with the foreground objects removed, Spitzer is able to capture the infrared light further away in the cosmic background. The James Webb is being designed to capture infrared light too, only its primary mirror is 7 times the diameter of Spitzer's, allowing much higher predictive capabilities. The James Webb has a large legacy to build upon. Before Hubble was launched in 1990, astronomers could barely see normal galaxies of 7 billion light-years away, about halfway across the universe. Observations with telescopes on the ground were not able to establish how galaxies formed and evolved in the early universe. Hubble gave astronomers their first view of the actual forms and shapes of galaxies when they were young. This provided compelling, direct visual evidence that the universe is truly changing as it ages. Like watching individual frames of a motion picture, the Hubble Deep Surveys revealed the emergence of the universe's infant structure and the subsequent dynamic stages of galaxy evolution. The infrared version of NASA's planned James Webb Space Telescope will be aimed at the extreme deep field patch that Hubble has been studying. The James Webb Telescope will find even fainter galaxies that existed when the universe was just a few 100 million years old, pushing the boundaries of astronomy even further. A special thanks to NASA and other governing bodies surrounding the Hubble Space Telescope. Without much of their video, 3D animations, and images, I could not have made this video. Check the links below to their various websites. I hope you enjoyed the video as much as I did making it. It took me roughly 30 hours. Please subscribe and check back for more. I plan on doing Hubble spin-offs for a video each on galaxies, nebulas, and our own solar system. I will also do a James Webb Space Telescope documentary when more information becomes available. Thanks for watching.